Okay, I'm going to share my screen.
Zoom meeting. Dina?
Okay, I have shared a PDF file to you. This is the basically a cancer report of Apollo Hospital 2024. Recently, a news has been released. India is a capital of the cancer. Basically, it's a hub of the cancer, and Northeast is a main vulnerability of the cancer disease. Now we will discuss on this and we will see the trend through Python and the real database. Uh, First, read this book, Apollo Health on the Nation 2024. According to this report, over the last 2 decades, non-communicable disease have been steady rise as the leading cause of the death in India, not only on the growth of NCDs but also their early arrival amongst the Indian population is alarming. And this report also tells that, see, uh, this is the data showing that the northeast, just see the northeast here, more than 30 people, the 30% area is affected in this area, that is central region, west, southern region, and this sea, Haryana, Punjab, this is northern region. This is a vulnerability of the cancer. See, the number of cancer cases in India on a sharp rise, with projections showing an increase from 13.9 lakh cases in 2022 to 15.7 lakh cases in 2025. The data represent a significant 30% growth in merely 5 years, alongside the cancer burden measured in disability adjusted life years daily is projected to the grown 27 million in 2021, almost 30 million by 2025. This is given the 2025. Now, our project is that we will this based on this data, we will simulate up to the 2056. Okay, after 25 years, what will the result? Okay, if this trend is going on, we'll see through this Python course and see lots of things. I have explained NumPy, pandas, matplotlib, arrays, matrices, uh, this one, the list, tuples, lambda, and variable. We have discussed all lots of things. The basic Python we have discussed. Now we are working on the middle, and we will do some project on this. Now open the Jupyter notebook. Okay, before open Jupyter notebook, I am going to explain some. Yes. Overview of the project. See, based on the Apollo Hospital Health of the Nation Organization Report 2024, we can focus on analyzing the prevalence and risk factor of non-communicable disease in India, particularly looking into data patterns and trends in disease such as cancer, diabetes, and hypertension. Okay, these are the main disease, non-communicable disease, but we'll focus on the cancer. The project will involve processing the analyzing health data to identify trends and insight that can add in healthcare planning and decision making. Why we are doing this project? Because we want to take a better decision. If we will not notice on this trend, then what will happen? If we will notice this trend, then what will happen? Okay, and this is the process called the decision making, and how this decision making will be helpful by Python. We will see the project overview. Objective of the project to analyze the trends in non-communicable disease prevalence in India using dummy data. That's similar to the report's finding. That dummy data means it is data is taken from the report. Scope: analyzing cancer incidence and its growth over time. Study the trends in diabetes and pre-diabetes rates among the different age groups. Evaluate hypertension prevalence and its rise in the population. Now, next part is the data simulation. We will create dummy data to reflect the trends mentioned in the report. Cancer cases increasing from 13.9 lakhs in 2020 to 15.7 lakh in 2025. This has been given in the report. uh, Diabetes prevalence in individual below and above 45 years of age. Hypertension trends showing the increase pre-hypertensive and hypertensive cases. Processing and analysis in Python. Simulate data. Generate dummy data set for cancer. Dummy data means this data is taken from this report. Diabetes and hypertension based on the trends reported. Data preparation. Create data frames for each condition using pandas and assign realistic values based on the percentage and trends mentioned. Analysis: use a statistical method to analyze the data, identify patterns and trends in the occurrence of these non-communicable disease over time. Visualization: through we will use the plot trends using matplotlib and cburn libraries. Generate graph to represent the growth in NCD cases. uh, Generally this graph, box plot, QQ plot, etc. Insight and interpretation: draw conclusion from the data analysis and visualization. Provide insight into the potential healthcare implication. Uh, we will explain the code during the executing. Descriptive statistics, we will descriptive statistics, evaluate the descriptive statistics. What are the descriptive statistics we will see, and we will check the cross validation through box plot, histogram plot. Now, in conclusion, these outputs will collectively provide a comprehensive view of the cancer cases, trends, its yearly growth, and the distribution pattern of the cases over the years. This information is crucial for identifying trends, assessing the rate of increase in cases, and understanding the overall variability and distribution of the data. For the Apollo Hospitals Health of the Nation Report 2024 project, we can use machine learning to predict trends or classify pattern in non-communicable disease like cancer, diabetes, and hypertension. We will use data that data is given in this report and demonstrate how apply machine learning for trend prediction and classification. Uh, Project scenario, trend prediction, and the classification. Classification is done by the machine learning process, and trend prediction is done by the predict future trend, future cancer industrial rate using time series forecasting. And for classification, we use the machine learning process like random forest and this AdaBoost processing. Data simulation, we will see that in theory part, the practical part. Machine learning approach, that is the trend prediction with linear regression for cancer intelligence, classification with logistic regression for diabetic risk. And what is a trend linear regression or trend prediction? We use linear regression to model the relationship between the year and the number of cancer cases, allowing us to predict future trends based on the past data. Logistic regression for classification. We apply logistic regression to classify individual into risk categories for diabetes based on the factor like age, BMI, and blood. That's why we are using the because it's a categorical data like age, BMI, and blood glucose level. The model predicts the probability of having a high risk of diabetes and we classify the individual accordingly. These machine learning approach provide a basics of understanding and predicting the trends in NCD, that is non-communicable disease, and can help in planning healthcare intervention more effectively. I will describe the expected outcome from the logistic regression and model and classification report based on the code provided for the predicting diabetes report. And this is the output, and we will discuss after the this practical. Okay, open your Jupyter notebook. How to open your novel from here? Just type the Jupyter and click on this. Open book. The first thing is import pandas library. For this, use the code import pandas as PD. Now import NumPy libraries, and for this import NumPy and NP, and import matplot.py pyplot module and alias is it as a PLT. Okay. We have discussed what is the library and what is the module. Module is a subset of the library and work under a library. That's why here written as PLT. It's a alias it as PLT. Now next thing is to simulate cancer incidence data from the report. For this, what will you do? First, create an array of years from 2020 to 2025 because this data is given. Okay, and it is well why I'm written here 2026 because in Python programming it is number is starting from the zero, not one. Then you have to write a one succeeding, that is 2026. It means if you will written here 2025, then it's basically represented 2024 because when you will write, let's see, first this is one, two, three, four. Then in Python, basically this will count as a indexing. One represent zero, two represent one, three represent four, and the four represent three represent two, and the four represent three. This way. Okay, that's why I'm written here the 2026. But basically, it is a array for from 2022 to 2025. This data is given in the report. Now create an array. Create an array of simulated cancer causes using NumPy. This function NumPy function, that is NP. the line space function, that NP line space function generated evenly spaced number over a specified interval. Here it generates numbers between 3.9 and 5.7 with the same length of the year. Then because in the same 13 point, it is in the lakh, which is given in the report which we have read. Okay, just go to the report and check. Cases arise in this. Okay. Then it multiplied by the each number by this 10 lakhs to convert from lakh to absolute number. Okay, because this is lakh, because in program you cannot write lakh is 100, simply multiplied by the this 1 lakh. Okay, then this will be 13.9 lakh and this will be 15 lakh. And length year from this to this. Okay, year is given. Take the length of this function. Okay. Now next, create a data frame named cancer underscore data using pandas. Pandas is, I have told you, pandas library used for creating a data frame, and how this can be created you have seen. Okay, the data frame has two columns, year and cancer cases, and this will be more clear. Just see, I'm going to generate some code cell below. Okay, now first thing, activate this library which we have discussed. Now next is simulate, and for this create a array. Now next is make a data frame, and in data frame there are two columns. One is the cases and year and cancer cases. You will see this thing. Now here write the cancer data, then you are able to see the data frame. See, these data are given in your report. Okay, to the 20, this one, and 21, this in cases arise in lakh. Okay, to 25, this one, and see why I'm writing the 2026, but it's up to 2022 to 25. Okay, now next things is that create a figure for plotting with a specified size using matplotlib. And for this you will use this function, this plotting part. Okay, this is the plotting part, and adjusting figure you will use this plot figure, and fixed size you can adjust the figure size. Now plot the data from the cancer data frame, which we have made a data frame, that is we have seen here, this one. Okay, and here the we will use the marker specify, and the marker specify is a circle, and data is given in a circle, and its line style is dash. Okay, and here the set the level for the x-axis and y-axis. X-axis is year and y-axis number of cases arise. Plot in the grid. You will see the grid. Now plot this. See, this is the grid, x-axis and y. Adjust the figure. Suppose that this is so big. Just 6. Now it is okay. See, the trend is increasing in every year. 2022 year cases are here. As the year is increasing, the number of cases is also increasing. That's why the India is the capital of the cancer hub. This is very serious matter. I've just seen the report in the news, so I thought that to make a project report and I deliver this to Ajay. Okay. Now you can show data visualization and you can clearly show that do something on this. Otherwise, this trend is increasing and no, and in a bunch of five people, the every after the five people, one people is affected by the cancer. Now, next things is that descriptive statistics. See, in data there are six count, which means 2020 year 2022 to 2025. There are six, and mean of the overall this is basically a scientific number because mean is very large, so it is written in scientific number e exponential. Standard deviation is this, minimum is this, first quartile is this, and the maximum value is this. Now cross validate this thing. Then year of the by checking year on year growth. Then year on year growth is 25%. If you check in the percentage, then now we will see box plot and histogram plot and adjust the figure because figure is so large. This is the histogram plot and this is for the negative skewed data. Okay, negative skewed. Uh, Basically, how negative skewed looks like. If you going, I'm open the this. No, no need to open. Okay, just see here. Just see. This is the positive skewed, which hump is at lower side. Here, on consider on the x-axis, and the tail is the higher side. This is called the positive skewed. But in this case, this is a negative speed. When you draw a density line, then hump is here higher side and tail is the lower side. This is negative speed. What is the meaning of this? This represent that just consider on this mean. Mean of this mean is something this is very large number. Just this number is very large. When just copy this one. And you will see how this number is large. Just paste here. How is this? See, uh, 14 lakh 80,000 is the mean of your data set. It means that when you will see this one in your data set, this is your data. Most of the data is greater than 50, this 14 lakhs. Just copy this one and I will show you the result. With this one, keep the filter. Just see, this is the 14 lakh 80,000. 14 lakh 80,000. It's 1, 2, 3. It means that the dominance of the greater than the mean value is the dominant part in your data when it is negative skewed. When it is positive skewed, then a dominance of the your less than the mean data. That's so it is showing a increasing trend. Okay. From box plot, what is the box plots? In this box plot, just see it is something different from this box plot. See, I want to say this box plot. In this box plots, see, first see the basic feature of the box plots. Go to the well, and I will show you box plot. See, are you able to see? This is basically called a box and whisker plots, in which this part is called the box and this part is called the whiskers, and in which so at the lower side that is it is called the minimum value and the upper it is called the maximum value, and here this is the upper quantile, this is the lower quantile, this is the median value. Okay, and a box plot what's showing the minimum value, so uh, the first or lower quartile, the median value it represent the third quartile and the maximum value. Now, just and beyond this minimum and maximum beyond the maximum, that's the outlier, and beyond the minimum value, it is called the inlier. See, in this outlier are present. It's basically in your data set when the outlier are present, then you can see that some anomalies are present. Anomalies is due to some extra activity, some anthropogenic activity, or something different is coming. It means anomaly is coming. But in your data set, there is no any outlier. It means that there is no anthropogenic activity is going on. There is no. It is naturally increases in the cases of the cancer. Okay, so we have to more aware of the because lots of things is the main reason of the this cancer arises. It is written in the report. The main reason of the cancer arises is not due to tobacco and these things, and due to radon gas. And radon gas is coming from your AC and this. Photographic Xerox machine this and in a every and each house AC is available, and this is not a some anomaly pattern. This is a usually pattern which we adopted in our life. That's why it is showing nothing here any outlier value. It's a very dangerous. Okay, if something due to the tobacco and this thing, then we will see the some outlier value and we stop the don't eat the tobacco, then you will save. But here scenario is something different. Okay, histogram plot you can see. Now we will linear regression model we will do. We have discussed about these things, how to import and this for linear regression. First we will generate some cells. first import this library and we will import numpy NP, import pandas as PD from sklearn.linear model, import linear regression, import matplotlib.pyplot as PLT. Okay, this is for the machine learning process because we are going to the future prediction with the help of the future forecasting with the help of the trend analysis, linear regression analysis. Simulate the dummy data is basically this data is coming from your report. Assume linear increase in the cases. If you multiply with the 50. This is we have created array. Okay. Generate some empty cell. Now prepare the data x and y because linear regression is a operand between two data. That is the first x is a feature year and the second is the targeted, that is cancer cases. We will predict the up to the 2030. Okay, predict the how this trend will show. Okay, prepare the data set. Now going to this has been done. Now going to the activate your model linear regression we have written. Okay, we have written model linear regression and this one. Linear regression model has been activated. Okay. Okay, now see the plotting result. See trend up to 2030. This trend is showing a increasing trend based on the previous data, which is a very serious concern. Now it's 2030. Now we will take the 2090. What will happen up to the 2090? Is there showing any decreasing trend or increasing based on linear? See, it's also showing a increasing trend. Okay, just like yesterday, if current scenario is going on. Okay, that's why the AC and this luxurious AC car and AC room are very luxurious things. But basically, this just go to the report because they emits the radon gas, and this gas is basically a responsible for the vulnerability of the cancer disease. Okay, so sacrifice these luxurious things. Now we will see some, as we have discussed, we will see linear machine learning process for two. One is we have discussed in this logistic regression classification. We have see for the we apply logistic regression to classify the individual into risk categories for diabetes based on factor like age, BMI, blood glucose level, and model predict the probability of having a high risk of diabetes and be classify individual accordingly. These machine learning approaches provide a basic understanding and predicting the trends in this NCDs and can help in planning healthcare invention more effectively. So we will see this one by one. Okay, and for this we have to activate this library. Okay, it has been activated from sklearn.model underscore selection import trend test and split, and from sklearn pre-processing import standard scalar, from sklearn.linear model import logistic regression, from sklearn.matrix import classification report. We have activated this library. Now next is simulate dummy data. Basically, dummy data is taken from your report and create an array. Now this for use NumPy, np dot NumPy is basically this acronym for NumPy random dot seed. It's seed means cycle. It is taken from the 0 0 means 1. It is indexing pattern. Repeating. Now age is defined 20 years, 70 or 100 years age range, and for this numerical Python and np dot random random function. BMI is between this range from not this is range from BMI is a range from 18 to 100 for this age. Blood glucose we have defined 70 to 100 range. Diabetes risk age is more than 50, BMI is more than 30, and blood glucose is 150, more than 150. Then high risk if any candidate is true. Okay, if fall any candidate between these, then we can say that it is a high risk. Okay. Now next is that prepare the data set, training data and test data. See an array, the data is given this way. Okay. Now standardize the data with the standard scalar field. We have to because when you will do the this logistic regression, you have to change this in a normal distribution, and the best way is normal standard scale in which zero mean and unit standard deviation, and this will after then converting this, then after the final modeling we will do the back transformation. We standardize the data. Now logistic regression model for classification. Now this logistic regression function has been activated. Now final predict and evaluate. With precision, recall F1 score support and explain these things, what is these are and what is meaning of this output. Okay, I have already written here. When you run the logistic disaggregation, as we have run model on this report data for diabetes risk, the classification report function will generate an output that includes several key metrics. First is the precision. Precision means the ratio of correctly predicted positive observation to the total predicted positive. It indicates the quality of the positive class prediction. Recall sensitivity, the ratio of a correctly predicted positive observation to all actual positive. It shows how well the model is capturing the positive cases. And F1 score means weighted average of the precision and recall. It takes both false and positive and false negative into account, and F1 score reach its best value at 1. Perfect precision and recall, and was at 0. All things is here given. I'm just explaining these things. F1 score and this when 1 is best and was is 0. Okay. Support the number of actual officers of the class in the specified dataset. For each class, high risk or not high risk of the diabetes, these metrics will be provided. Additionally, there will be a section for overall averages. Accuracy, the ratio of correctly predicted observation to the total observation. It gives the overall effectiveness of the model. Micro average and averaging the unweighted mean per level. Weighted average, averaging the support weighted mean per level. Precision for 2 indicates how accurate the model is when predicting high diabetes risk. Recall for true shows the model's ability to detect all relevant cases of high diabetes risk. And we will summarize this thing. The F1 score provides a single score and that balances both the precision and recall for the true class, indicating the model's overall accuracy and for detecting high risk individual. Uh, Now, this is the explanation of this and showing overall it is showing that vulnerability is high risk. It's a 91, weighted average is 91. It's showing that the risk is very high and high, which age is more than the 50 years. Now, come to the feature work in this. Enhancing feature engineering, more sophisticated. What is the feature works can be done in this way. Enhancing feature engineering, more sophisticated feature can be derived from the raw data to improve the model accuracy. Model tuning, you can tune the model with the help of the more advanced machine learning process, that is the random forest and hyper. It's a very advanced technique. This is a deep learning process. Temporal model, with time series data, it is available model like ARIMA, LSTM, or GRU can be employed to predict trends over time. Explaining AI and XAI, implementing XAI method to understand the model decision, especially import in healthcare to gain trust from the medical professional. So overall, this is a project we have done on a cancer data. Now you can apply these Python knowledge on your own project. Now we will see some uh, another project that is a special data project. Okay, uh, we have a data set. Okay, just wait. We have a data set in which X, Y, Z and groundwater level depth and hydraulic head has given. Uh, these are the parameters, and basically X variable, X is a X coordinate, this is a position, and Y is a Y coordinate. This is basically called the X is sting and Y is northing, and Z is elevation or altitude, and depth, groundwater level depth is basically a uh, water level depth from the ground surface. You can understand these things from here. Uh, this is your ground surface, and this is your water level surface. Okay. So from you will measure from you are standing here and measure with a moisture content moisture meter and just see and read the reading, and suppose that this will be 5.1 meter. Then this is the called the groundwater level depth. Okay, I'm just basically explaining this. Now this is your datum plane and you are standing here. From here to here distance is called the mean sea level. Distance from mean sea level. You have listened the mean sea level. This just give me 1 minute. Okay. Okay, and this is basically a data, and from here to here, this is your suppose that aquifer body, and from here to here, this is called your water level. This is the your water level. When you subtract from this distance to this distance, then you will get the hydraulic head, and this is the your fourth parameter, that is the hydraulic head. Now we will see some project on this, how Python will deal with the special data. Okay, the first things you have to call these libraries. import pandas as PNG, import matplotlib.plt as PLT, import cburn as SNS. From SciPy import stats, import geopandas as GPD. From shapely.geometry, import point. Okay. Path for your CSV file. Basically, I have keep this file in a folder name is a data2csv, and this is the path, and R is for the readable file. For read file, we have discussed the readable file, writing file we have discussed. Okay, now run this and just see your in a data frame. This one, and use the PD. PD is a pandas taken from the pandas library. Now this is the path. Now we will see able to see the our data frame. Okay, XYZ and this. Now we will see box plot of this. See here the maximum minimum value and the vulnerability of this outlier value in our data set is this. Now descriptive statistics for the our hydraulic head. The minimum maximum is 77 number of data present. Mean is this 178, and the standard deviation this, and this one. Now we will see the QQ plot. QQ plot will basically check for the normality of the data. If these dotted line is basically horizontal head data aligned with this state line, then we can say that our data is normal. But this is not a normal distribution. And what is this distribution? This will clear from the histogram plot. Use the histogram and see clearly it's a hump is a lower side, and this is a that is the higher side. It which shows that the data is a positive skewed. And positive skewed means your mean value of the dominance of the more than the mean value. Now we will do some special data and how this looks like. See special plot of the hydraulic head, and for this we will use the geopandas and geodata plot and this. See the value of the maximum 400, and the density of the higher level of the hydraulic head is this side, and lower level is this side. We will do more project on the next day tomorrow, and this same from 4 p.m. If you have any question, please send me the chat box. Siraj sir, hello, Siraj sir.
Yes, sir.
Yes, sir. Please summarize, and I have finished these things because I have to go somewhere else. Now this is more discussed.
Sir, at least by 6 p.m. we can. Simap, sir. By 6 p.m. we can. Simap, sir.
Yes, sir.
Sir, till 6 p.m. you can, sir.
Yes, sir.
At least
Sir,
till 6.
I have some meeting, another meeting. Somewhat, it's very urgent. I will compensate next day. Don't worry, we will compensate for 2 hours. Do these things I have shared to all things. If you have any question related to this, you cannot understand because I have explained all the how you can use this Python knowledge for a project implementation. I have discussed. If you have any problem, please send. Please ask me. Because I have someone is waiting for me, and I am very urgent. I have to go.
Okay, Simap, sir. At least share this recording as well as PPT.
Yes, sir. I will share because due to internet issue, I cannot share the previous video. I will share this video and the previous one.
And kindly share your number also, so that if any queries, they can talk to you through
yes,
WhatsApp.
I have already shared my number to all of participants in WhatsApp.
Once again, please. Once again, you can share. Simap, sir. Once again, you can share.
Okay, sir. I will share the thing in WhatsApp group.
Okay, sir. Thank you, sir. Thank you. Simap, sir.
Yes, sir.
Tomorrow at what time we'll start the session?
Yes, 4 p.m. Same time.
Same time, 4 p.m. Okay, fine.
And we don't miss the tomorrow class because At the end of the class, we will learn lot of things. Okay, sir. Thank you
Okay.
so much for joining and uh,
Okay, sir. With this, we'll stop here. Once again, we will meet tomorrow 4 p.m. Simap, sir.
hello.